We are now going to start working on the handout titled Domain and Range of Functions. We're going to talk a little bit more about domain and range in detail and exactly what you need to know about these. In this class, we just study functions that have domain and ranges that are sets of real numbers. And that means that our domains and ranges will be able to be described using interval notation. Interval notation will be our preferred way to write answers to these kinds of problems. So in the box it says the set of all input or x values for a function is called the domain of the function. The set of all the output values or y values is called the range. So example, describe the domain or range of f of x equals x squared. This is the squaring function, an example that we've talked about quite a bit, and it's one of our toolkit functions, so we just graphed it a little while ago, right? There's the graph of that x squared function. It's a famous shaped curve called a parabola. And we're just going to read this one in words. The domain consists of all real numbers, since any real number can be plugged in for x. In interval notation, we write this as the domain of f is the interval from negative infinity to infinity in parentheses. That just means all real numbers in interval notation. Since the outputs are all greater than or equal to 0, meaning the y values of points, and include all numbers greater than or equal to 0, that set is precisely the range of f. In interval notation, we would write the range of f as square bracket 0 comma infinity parentheses, that interval. So the domain refers to an interval of x values. The range is an interval of y values. Now let's go ahead and start these exercises. Exercise 1, I've recopied on a sheet of paper. We're going to describe the domain and range of a particular function, and we're going to figure this out from a graph. We're not always going to have to graph, but when we have a graph, it's actually a lot easier to think about what the domain and range of a function actually is. And so here we want to describe the domain or range of this function, square root of x plus 1. This is very closely related to another one of our toolkit functions, and it shouldn't be too hard for you to generate a graph. We'll go through it in a little bit of detail here. And I already set up a table of values. I'm just going to plug in some x values to get some points to plot. If I plug in negative 2, I'm trying to take the square root of negative 2 plus 1, but I can't take the square root of negative 2, right? Because that's not a real number, so there's no point to plot. Square root of negative 1 plus 1, I have the same problem. I can't take the square root of negative 1. But at 0, I can plug in 0. Square root of 0 plus 1 is just going to be 1. Square root of 1 plus 1 is going to be 1 plus 1, or 2. Square root of 2 plus 1, square root of 2 is about 1.4, so I'll use a calculator to help me get a decimal here. So my y value is actually about 2.4, right? Because I add 1 to 1.4. Square root of 3 plus 1, let's see, square root of 3 is, on a calculator, if I check, it's about 1.7 plus 1, so I'm getting about 2.7. And at 4, square root of 4, just come down here a little bit, plus 1 is 2 plus 1, or 3. So I get a whole bunch of points to plot here. And I notice that when x is negative, I have no graph to draw. At 0, I have the point 0, 1. Then I have 1, 2 to plot. I have 2, 2.4, 2, 2.4. I just have to approximate that. 3, 2.7, a little higher. 4, 3, exactly. 1, 2, 3, 4, 3. And so the shape is very much the shape of the square root graph that we've graphed in our toolkit. And I think you can see we're starting at a certain point here, and we're rising up slowly to the right. In fact, another number that's not hard to plug in is 9. Square root of 9 is 3. 3 plus 1 is 4. So at 9 we get 1, 2, 3, 4. We're going to slowly rise up like so and go on and on forever. But this graph, I'll put a little arrow to show that, this graph definitely just starts at 0. Okay. So now let's describe the domain of range. First, we'll describe the domain of this function. And to do that from the graph this is a kind of a easy graph to work with in this case, because we want to describe all x-coordinates used by points on the graph. Well, we never use negative x-coordinates for points on the graph. In fact, the very first one we use, you might say, is 0. And I'm actually going to imagine projecting this graph down onto the x-axis. And what we get is, it's kind of like we get a portion of the x number line. We start at 0, and we go on and on and on to the right forever. So in a sense, this red portion of the number line I've colored in represents the domain of this function. If I project the graph straight on down vertically onto the x-axis, I get the domain. So the domain here, I have a closed-in circle at 0, so square bracket 0, comma, on and on and on to the right is infinity, parentheses. There's the domain of our function. Okay. Now we also want to describe the range, and I can also get that from a graph. And I'm going to just redraw my picture. Now you don't normally need to draw two graphs, but it's a little bit easier for me in this video to draw a picture if I have another graph here to illustrate the range if I have another graph. So I'm just recopying the same graph. And again, normally using just one graph will work for both. But what I want you to see here is that when we look for the range of this function, we're looking at an interval of y coordinates, of y values. So visually on the graph, the way we can think about the y values of all points on this graph is to flatten the graph or project the graph sideways onto the y-axis. And notice there's going to be a point right here, 1 up on the y-axis. And then as that graph extends, it's going to project onto the y-axis onto values greater than 1. So remember our initial point there was 0, 1, so y-coordinates 1. So this shaded portion, red portion of the y-axis is a picture of the range. Now, the range we always kind of see sideways, right? Because it's where we draw the y-axis up and down. So you might have to tilt your head sideways to think about the range. It's an interval of y values. It's understood. And for this function, it starts at 1, square bracket 1, comma, on and on forever up along the y-axis is to infinity. So we have our domain and our range for this function that was square root of x plus 1. And we got the domain and range by using the graph, right? The domain is an interval of x values. The range is an interval of y values of points on the graph. And we'll continue in a separate video.